All right, our next problem wants us to find the component form of the vector that represents the velocity of an airplane that's descending at a speed of 150 miles per hour at an angle 20 degrees below the horizontal. From the previous side, we said that the component form of a vector looks like this, which is what we've got down here. So we've got the magnitude of v times the cosine of theta I, that's your horizontal component. Then the magnitude of v times the sine of theta j, that's your vertical component. So, and then we've also got a picture here of what this looks like. Okay, here's your airplane. So let's see, we want to write a vector for this. So the magnitude of v, that is already given. That is the speed. So we have 150. We were told that our angle is it's 20 degrees below the horizon, which if we add 180 to that, it's going to be a 200-degree angle. So cosine 200. So that whole thing, I, plus 150, same magnitude, sine 200, oops, j. Okay, so all we're going to do is put this into our calculator. 150 cosine 200, so I get negative 140.95 I, and 150 sine of 200, negative 51.3 j. And I think this is the form they wanted it in, vector form. So negative 140.95, negative 51.3. The one that's a negative sign. Okay, so those are the components of our vector. That's all they were asking for there. All right, so this, if you're taking physics, this should look really familiar. We have a force of 600 pounds is required to pull a boat and trailer up a ramp that's inclined at 15 degrees from the horizontal. We want to know the combined weight of the boat and trailer. There's a really nice picture of this on page 585 in your book. I will do my best to recreate it. So we've got this boat ramp here, and then this is the little trailer. So I make really nice trailers. There. So this is a 15-degree boat ramp. And we need 600 pounds is required to pull this up. So 600 pounds is required there. We want to find the combined weight of the boat and trailer. Okay, weight always acts this direction, okay, in the vertical direction, so we'll call that x. And then what we'll do is we're going to take this 600-pound vector, and I'm just going to translate it down here. Okay, so this will be our 600, and then we'll be able to make a right triangle out of that. And again, this picture's in your book, in case my drawing's not very good. So if this is a 15-degree angle, that means that this is also a 15-degree angle. It's very sloppy. So what do we know about this? Well, this is just a right triangle, so we can use our basic right triangle trick. We know a 15-degree angle, and we know the side opposite of it, and we know the hypotenuse. So opposite and hypotenuse, we're going to take sine of 15 equals 600 over x. And then we're just going to solve that quickly. Divide both sides by sine 15. Um, 600 divided by sine 15 is going to be 2318. Okay, so the combined weight of the boat and the trailer is going to be 2,318 pounds.